Continuous uniform distribution. Continuous implies that there are infinite number of outcomes that are possible. And at the same time, uniform implies that each fixed set of outcomes are equally likely. So let's see how we could translate these interpretations into a visual framework. So we can see that the outcomes are continuous. In other words, there's no break in between these outcomes. Now, the lowest outcome possible is A, and the highest outcome that's possible has a value of B, and there are an infinite number of possibilities in between A and B. Now, notice that, and here's where the uniform comes in, the probability of each fixed set of events, so if you just pick the fixed set of events, the probability of this block would be the same as the probability of that block, and it'd be the same as the probability of that block. So each block of outcomes, as long as they're equal blocks, will have the same or uniform probability. So what are the metrics that we want to compute from a variable that exhibits a continuous uniform distribution? First of all, we like to know what the expected value is. So again, I realize that there's an infinite number of values that are possible between A and B, but with any data set, even if it is continuous, we like to see what the average is, or the expected value. So all we do is we add A plus B and divide it by 2, and that gives us an idea of what the middle or the average value is. Now, whenever we compute average, we also want to know what the variance or dispersion is around that average. And the framework for calculating variance for a uniform continuous distribution would be the following right here. Now, there are very few frameworks that I ask candidates to memorize because I like to build everything from the ground up. However, in this case, rather than spending a big chunk of time trying to look at the rationale behind this, I think it's just a lot easier just to commit this to memory. So when you're asked to calculate variance for continuous uniform distribution, this is your framework. So now let's do an example. Suppose that inflation exhibits a continuous uniform distribution with a range of 2 to 8%. So what that means is inflation can take on any possible value between 2 and 8. So in theory, if the lowest inflation number is 2, the next one would be 2.00000000001. That would be the next outcome, and that's the whole definition of continuous. So just with that simple illustration, you could see that there would be an infinite number of possibilities between 2% and 8%. And at the same time, it says continuous, so each range of inflation is equally likely to occur. So what we want to know with any data set, ladies and gentlemen, it doesn't matter what the distribution of the data set is. We like to see what the average is of the data and what the variance is of the individual observations around that average. So first, let's start off with the expected value, or the average. Well, if you've got the lowest possible inflation is 2, the highest one is 8, the middle would be 5%. So we just add up the two values and divide it by 2. And to calculate variance, so this is the framework we're going to use. So it's just a matter of plugging in the numbers. We get 3, but you have to be careful. That's variance. And what we like to do is we like to express dispersion in terms of standard deviation. So we got to get rid of the square through square root. So the square root of 3 is 1.73%. And the way to interpret this is as follows. So within this database, we expect the average inflation to be 5%, but on average, the individual inflation rates vary by 1.73% from this average. Part C, we're asked to calculate the probability that inflation will be equal to 4.3%. So you can see this is a specific outcome. So it's one of an infinite number of outcomes. Remember, because we have an infinite number of possibilities between 2% and 8%. This is just one of them. So what do you get when you have just one outcome out of an infinite number of possibilities? You get 0. So what's the tip? With an infinite number of possibilities or possible outcomes, each will have a probability of 0. So that's why, ladies and gentlemen, when it comes to continuous variables, we're not trying to calculate probability of an outcome, because in a continuous distribution, the probability of seeing one number is 0. So what we do is we like to calculate probability of a range, or it's referred to as an event. So an event is a range of outcomes. So you could see that we have a range of outcomes from starting from 2, in this case, until 4.3. So I jumped ahead a little bit, but let's see what the question is asking for. What's the probability that inflation will be less than 4.3? So do you see the difference between these two questions? Part C is asking you for the probability of just one outcome. Part D is asking you for the probability of a range of outcomes, in other words, referred to as an event. So let's use our framework for continuous uniform distribution. 2 is the lowest value, 8 is the highest value. What is it they want? The critical point is 4.3, and they want to know this area right there, because remember, we associate area under the curve with probability. So how do we find? So we know the total area is 100%. So what fraction of the 100 does this represent? Well, let's see here. The total goes from 2 until 8, so that's what we have. So the total range is 6. And how far in do you want to go? I just want to go from 2 till 4.3. Well, that just represents 2/3. So therefore, the probability of this red shaded area is 2/3 of the total 6. And that works out to 38.3%. So in effect, this 38.3% represents this area right there. And now in part D, we're asked to calculate the probability that inflation will be between 4.3 and 5.7. Same process, ladies and gentlemen, same process. Here's our minimum value, maximum value, and the author is interested in this shaded area over there. So what does a total box represent? In other words, this whole range of outcomes. Well, you know, that's going from 2 until 8, so that represents a range of 6. Now, what fraction are we interested in? We're just interested this part right there, and that represents 1.4. So to get the area of that red shaded area, it's just 1.4 divided by 6. That works out to 23.3%, and this would represent the probability of that range. So if I had to answer this question head on, there it is. So the probability that inflation would be anywhere between 4.3 and 5.7 is 23.3%.